Web servers are the underlying structures that help deliver content to end users, most typically through public internet access. In this module, we'll look at common web server attack tools and methodologies used, as well as countermeasures and security practices. We'll also talk about the importance of patch management in regard to securing a web server. Web servers are prevalent in modern networks, so we need to understand the threats to this type of infrastructure. Web servers are defined as systems which deliver contents to end users through Hypertext Transfer Protocol, or HTTP. These contents could be web pages, that could be media, photos, or just any general type of file. We use this all the time without even thinking about it when we browse the internet. Many websites are built on Apache. Apache is one of the most used web servers in the world currently. Now, before we discuss some common threats to web servers, let's talk about what we call the vulnerability stack. This is going to be relevant here for web server threats and later for web application threats as well. So this is a common way that we can visualize the various vulnerabilities and areas that we need to be concerned about as security professionals. At the bottom, we have our security level. That would be our general network security devices like firewalls and intrusion prevention systems. Next, we have the network layer, where we have our infrastructure devices. That would be things like routers and switches. Next, we have our actual operating system. Common operating systems, of course, include Windows, Linux, and Mac OS. Next are our databases. Popular database platforms include Oracle, MySQL, and MS SQL. Next is where we see our web servers, providing a connection between end users and the database. Common examples of this include Apache, as we mentioned earlier, and Microsoft Internet Information Services, or IIS. Next, we have third-party components such as web applications, which provide access to the web server. And finally, we have custom web applications that are typically business specific. These have been created to serve end users in a very specific way. So we have 7 total vulnerability stack levels. Now, most of the time, it's fairly easy to defend against the lower levels because we can implement firewalls and IPS. We can use good security features on our routers and our switch infrastructure. Our operating systems and databases should be safe if we're properly patching and updating these. So all of these layers are difficult points of entry for an attacker. And also they're behind local resources. So for this reason, attackers will often turn to the upper levels. They'll attack web servers and web applications which are accessible from anywhere over the public internet. So let's talk about some of the threats to web servers. Some common threats, which you're probably not surprised by to see listed here, starts with unpatched and or non-updated web servers. If we don't update those with the latest patching or software, then they're obviously vulnerable. Also, running unhardened applications and unhardened servers as the underlying infrastructure can allow threats to emerge against a web server. Another common one is using the same administrator credentials in numerous places, or leaving default credentials in place. This is definitely low-hanging fruit from an attacker's perspective that can be taken advantage of through various password tools. And allowing unrestricted internal and outbound traffic is an oversight as well. Other threats to web servers include misconfigurations. This is a big one. That would include misconfigurations for the web server itself, also for the operating system, and even the underlying networks. Unnecessary services or ports being available is also risky, especially if we have remote management services running or those ports available. And improper file and directory permissions, in other words, giving the average user too much access to the data in the database. Let's talk about some reasons that web servers are attacked. In other words, what are some common goals for an attacker? And obviously, these can range across a wide variety of things. The valuable data stored inside of the database is the main reason, and that could include credentials to other places on the network, or depending on the database, there might be financial information in there, just as a couple of examples. It's also possible that the attacker simply wants to wreak havoc with a denial of service attack, or maybe they're trying to integrate the system into a botnet for a larger distributed denial of service attack against a completely different target. And you also can't discount the fact that this sometimes happens just out of sheer curiosity, where an attacker is simply trying to check their skill set to see if they're able to compromise a target. We've mentioned a few reasons for these attacks, but let's also outline some specific web server attacks that we do commonly see. Of course, DOS and DDoS attacks that we just mentioned are common. We may see these play out as man-in-the-middle attacks as well. This can happen when an attacker poses as a proxy, luring a victim into connecting to a web server. The attacker, as the proxying device, can then intercept all communication and steal user data and credentials. And various DNS attacks are common as well. Things like DNS amplification and even DNS server hijacking. These DNS attacks are used in order for the attacker to reroute traffic to a different website that may be under their control, which they can use for nefarious purposes. Before we look at some specific tools for web server attacks, let's talk about the methodology for web server attacking. Just like with our hacking methodology that we've previously discussed, understanding the steps used in a typical web server attack will allow us to understand and recognize the hallmarks of such an attack. And as ethical hackers, this is also the methodology that we would use when we're testing web server security ourselves. Phase 1 is information gathering. No surprise here. Attackers want to gather as much information as possible using a wide variety of tools and resources. This helps to assess the current security posture of the target, and most likely this will leverage online resources and OSINT tools. Some of those same tools are the ones we mentioned in a previous section of this course. Things like Whois lookup tools and DNS tools. Another important place that information gathering can happen specific to web servers is something called the robots.txt file. The robots.txt file is a text document hosted on the web server, and that is used to provide instruction for bots. Now, there are good bots like search engine crawlers or newsfeed bots that actually look for this file before they crawl and index the rest of the site. If that file is poorly written, it's possible to learn information from this text file that should be hidden, such as the entire website directory structure. These can be accessed by entering the URL of the web server followed by a /robots.txt, and you could do that in a browser address bar to see the robots.txt file. Phase 2 is footprinting. Here, just as with our hacking methodology, we're trying to obtain as much information as possible, using enumeration tactics to discover account details, operating systems, and versioning information, as well as database structures, server host names, and more. There are specific web server footprinting tools available, such as Netcat. This is a popular option. This can perform what we call banner grabbing. Banners are text displayed by a host server upon connection, and that banner can contain information about the server, particularly if it's not configured correctly or if a default banner configuration is left in place. By banner grabbing, we're often able to see software types and versions, among other things. So this is one of our main tactics for footprinting a web server. Other methods for footprinting are going to mirror those discussed earlier in this course and would include things like Nmap to discover services and ports open. Essentially, anything that we can use to enumerate a web server and to learn more information. Phase 3 is website mirroring. As you might guess, this involves completely mirroring, or in other words, copying the entire contents of a website onto a local hard drive. This offers the attacker the advantage of having lots of time to map the website's directories in a mock lab environment. So this allows them to perfect the potential attack before they begin. And also, it gives them the possibility of identifying interesting directories ahead of time. If they're able to successfully breach the server, they may then attack these interesting directories that they've previously identified through website mirroring. There are many tools out there which will perform website mirroring, including HT-Track, Visual Web Ripper, and Collector Studio, among others. Phase 4 is vulnerability discovery. Using all of the information we've gathered, we now want to look for an entry point. We looked at the exploit database website previously in this course, and that would certainly be a valuable resource for discovering potential vulnerabilities. In this phase, we're doing research. We're looking at public repositories for vulnerability information. And we want to specifically look for exploitable vulnerabilities related to the web server operating system, the web server version, and all of the other information that we've discovered through tactics like banner grabbing. We're looking for vulnerabilities that will specifically work against this web server. And some of the things we're trying to do with these vulnerabilities is we're looking for ways to either bypass security mechanisms or to maybe escalate our privileges. Phase 5 is session hijacking. We may go right to this step if our vulnerability scanning and information gathering doesn't reveal any potential vulnerabilities that we can leverage for access. We may also just determine that we want to use session hijacking as a method. When legitimate users connect to a web server, each of those users have a session ID. With session hijacking, we are sniffing or capturing web traffic in some way in hopes that we can see a valid session ID's traffic. This commonly happens through tactics like cross-site scripting, and we have a wide variety of automated tools that will allow us to attempt session hijacking. One of those is Burp Suite. There's a proxy feature that will proxy traffic through there, and that's a helpful tool for trying to hijack session IDs in sessions that are already established. Another helpful feature of Burp Suite is the sequencing tool. This tool tests out the randomness of session tokens, and it does that in an attempt to try and predict the next possible session ID token in order to take over that session. And phase 6 is web server password hacking. We've likewise previously discussed versions of password attacks, and all of those principles and techniques apply here. This can include things like dictionary attacks, brute force attacks, rainbow table attacks, simple password guessing, and any other type of password cracking procedures. We've looked earlier at an example of this using Hydra, and some other popular options include things like Hashcat, Encrack, and Rainbow Crack. Let's look at some tools now for web server attacking. And we're going to start here in Parrot OS. We're going to take a look at how we can do this from the perspective of Metasploit. Metasploit is a very powerful tool, and it has lots of exploitations already built in. So let's suppose that we want to scan against a web server. Now in my case, I already have an OWASP BWA virtual machine that we've looked at previously. So here in Parrot OS, I'm going to start an nmap scan against that machine, and that is at 10.0.2.4. So as we've looked at already, the first phase in capturing some information is, of course, fingerprinting and enumeration. And we looked at several tools for that already in this course. We talked about several of those in our web server hacking methodology, one of those being nmap. So nmap here is going to scan for any sort of open ports and services, and it's going to return back some different versioning information that will hopefully help us identify a potential vulnerability that we can take advantage of. If we're able to find one of those, then we'll jump into Metasploit and see if we have some exploitations already built into that, because there's a good chance that we do. So here we see now our nmap is completed. We do have some information. And one of the things that I'm interested in here, again, we're attacking web servers. So we see Apache. I already mentioned in this course that Apache is one of the most popular web service platforms. And in fact, here with OWASP, we see the Apache Tomcat engine. Now, this is a well-known vulnerable version of Apache. So if we have a case where we're scanning against a web server and we discover that there's a vulnerable version running, then that's definitely good news for us. Now, if we don't know whether or not that's vulnerable, then obviously we can take this versioning information that we've gathered. We can continue to do research by searching online at places like exploitdatabase.com, and we can see if it's vulnerable. Now, in my case, I already know that this is in fact a vulnerable version. So the next thing I'm going to do, I'm going to run the MSF console command, and I'm going to launch Metasploit here inside of Parrot OS. So we have that up and going. So let's do a search for any available modules related to Apache Tomcat. And when we do that, we have 19 results, it looks like. And to begin with, one of the interesting things that I'm going to look at here is the auxiliary scanner. This is a manager login scanner. It will try to brute force attack this login. So let's say we can see that's module number 15. So let's say use 15. We will set our host, the remote host in other words, to 10.0.2.4. That is the IP address of my OWASP BWA virtual machine. And we can say run or exploit to get that up and going. When we do that, you'll see our brute force attempts starting, and pretty quickly we did have a login success. We have the username root and the password is OWASP BWA. So we were able to brute force this login. Now we didn't have to give a path for a password list in this particular module that we used because that's already configured to scan the password from a specific list of the Metasploit word lists that are included with exploit. Now, if we did have an appropriate word list, if we have a larger one than we have by default with Metasploit, we can of course select our own. We could run that with our own word list. But in this case, we did have a success, so we can move forward. The scanner discovered valid credentials with the username root and the password OWASP BWA. So the next thing we want to do is select an appropriate exploit in order to gain access to this remote web server, and we're going to do that through the Apache Tomcat service. Now, the Metasploit framework has a specific module that can be used to execute a payload on Apache Tomcat servers that are running the manager application. So let's take a look at that. If we actually scroll up in the list where we previously performed a search, you'll see that module number 6 is the exploit to take advantage of this code execution. So let's scroll back down, and this time let's say use 6. That's module number 6. You can see that this is the exploit to take care of the Tomcat Apache service. So now that we're all set to use that, let's see what options we need to set. We can do that by saying show options and hitting enter, and you can see these are all of the options, or some of the options at least, that we need to enter in order for this to be successful. Some of those things are going to be the HTTP password that we discovered, the username, our hosts, which is our OWASP target, the remote port that this is listening over, and our listening host as well, which is already set to 10.0.2.15. That's our local IP address. So let's begin setting some of these. Let's say set our host 10.0.2.4. Again, that's our OWASP BWA. We want to set our port to 8080. If we scroll all the way back up to our nmap output, you'll see that this Apache Tomcat service is running on port 8080. So that's the port we want to use. We'll go back down to the bottom and hit enter to set that. Let's also set the password and username, and you can see we indicate those. If we look in our output of our show options here, we use HTTP password and HTTP username. So let's say set HTTP password, and that password was OWASP BWA. Let's set HTTP username to root. Let's also set the listening host. That's our own IP address, 10.0.2.15. And with all of that in place, we can say exploit and let this do its thing. And pretty quickly, you can see that we now have a Meterpreter session open. So this exploit has been uploaded to the Apache Tomcat server using a put request. The exploit actually worked, and now we have a shell on the remote target. From here, we might want to say something like sysinfo, and if we hit enter, you will see our computer name, you'll see our operating system, and so that's good. We can also say shell if we want to start a shell command. And from here, we can say who am I? and you'll see that we are the root user. So again, we're working inside of the actual Apache Tomcat server. So that's a way that we can use Metasploit and some of the built-in exploits to take advantage of a web server and to attack that. A couple of other options that I do want to mention for web server attacking. Metasploit, of course, is only one example of that. There's also something called THC Hydra. That's an option. You can see the GitHub page listed here. We also have something called Hulk, and similarly, you see the GitHub repository for that. And another popular one is called W3AF, Web Application Attack and Audit Framework. So these are all automated tools that are going to try and help you find and exploit web application and web server vulnerabilities. Let's expand here on some countermeasures that we can use for securing our web servers. We've mentioned a few dangers already, so let's talk about how we can circumvent these. In a typical network, we have several zones, ideally, that we create with a firewall. Commonly, we will have a designated inside zone containing trusted and private machines, and we'll have an outside zone where things are public and untrusted, such as our connection out to the public internet. We also commonly see a zone called the DMZ, the demilitarized zone. Ideally, the DMZ is where we want to place things like FTP servers, email servers, and of course web servers. Having all of these different zones creates more security barriers, which is good for our web servers. The web servers, in the case of a DMZ, they're now isolated from both the internal network and the public network as well. This can help prevent attacks from outside devices because we're able to more strictly limit traffic to and from the DMZ, as opposed to the way that we might be able to do that for our inside or outside networks. So we can be more restrictive with the DMZ. So good network design is critical for web server safety. That's the building block of web server countermeasures. Patching and updating is also a big consideration, as it is with all of our critical infrastructure. So let's talk about some general considerations for the configuration of a web server. This, of course, includes regularly scheduled scans for vulnerabilities, using the tools that we've already seen in this course, among others. Patching and updating should also happen frequently in an ongoing manner. We should avoid using any default configurations that may be in place during the initial installation. We want to remove those. Now, this is a step that's easy to overlook because these initial default configurations make things easy for us to get up and running quickly and to deploy a web server. But having those in place can create a situation where we'll have well-known credentials in place or maybe well-documented loopholes that will provide access to our web server. And since these web servers often host critical applications and databases, we want to ensure that we are performing periodic system backups as well, just in case we have a patch or an update that breaks our server, or if we have an attacker who comes in and wreaks havoc in there. I've seen this happen several times throughout my career where a well-intentioned patch or update caused system instability or even situations where the system couldn't even operate at all. If you're unable to roll back a patch due to some sort of strange issue, then your only resort will be to restore from a backup to get everything up and going. So it's a good idea to perform these backups not only on a regularly scheduled basis, but also before any patch or update deployments. So you maybe even would want to consider scheduling these things closely together. We also have considerations for accounts on the web server as well. We want to make sure we remove any unused or default user accounts that were created during the installation of an operating system, or those that may be in place by default with the initial configuration. With user accounts for the web server, make sure we have good, strong password requirements in place. This is going to help circumvent situations where password attacks could be successful. If we have strong passwords, it's going to greatly slow down attacks like dictionary or brute force attacks, and it can even render them useless if our passwords are strong enough. For administrator accounts on the web server, keep track of those and make sure they're limited to only the appropriate number of users who actually need that access. The more administrator accounts that we have, the more opportunity there is for valuable credentials to be lost or stolen. And you want to make sure you maintain logs of user activity on the web server. Ideally, those logs would be kept on a separate machine in the network. A centralized log collection device such as SolarWinds or Splunk, they can do this very well, and they can even store the logs in an encrypted manner so that they don't have the ability to be altered. Having records of who accessed the web server and when that happened is great information to have if you're investigating a security incident. Protocol considerations include that we, of course, are blocking all unnecessary ports and services. Anything on the web server we aren't using, that should be shut down. So, for example, there's no reason to have an FTP port open if that's not being used on the web server. That's just going to allow a potential entry vector. If we're using remote access for management purposes, we want to make sure that we're using a secure method for connection. If we're using something like VNC, this has known vulnerabilities. It's susceptible to attacks. So we want to use a stronger method, maybe something that is encrypted for remote management like SSH. The underlying network infrastructure will also be susceptible to protocol weaknesses as well. So you want to make sure that your underlying hardware structure is also being updated and patched consistently. That includes firewalls, routers, and switches. And this would also include routing protocols as well. Many of these routing protocols have their own security mechanisms, so that's a consideration for the network security team. And we need to think about the actual web server directories as well, and the files inside of that. This would include disabling directory listing. This is a web server function that displays the directory contents when there is no main index file for a specific web directory. So for example, let's say someone goes out to a URL. I'm just going to use an example URL here. Let's say they try to go out to wordpress.com/admin. If there is an index file in place, that's going to automatically return the website. But if a particular index file does not exist and directory listing is enabled, then the site would return back an actual listing of the directory contents, or in other words, what's inside that directory. This can include sensitive files or logs in many cases. This is a common misconfiguration found in many web server configurations. Frequent log checking is also important, particularly data access logs. We already talked about the importance of having these, and you want to keep an eye on those for any unusual activity or access from users. Patch management is the process of applying updates to software. Typically, these patches, or fixes as they're often called, are created and deployed by vendors in order to correct vulnerabilities that have been discovered. Those vulnerabilities may have been discovered by the vendor themselves, or it could be through an independent security researcher. Various ways these can be discovered, but regardless, security patches are critical to the health of our network infrastructure as a whole, and certainly specifically to our web server. With web servers, let's look at the typical process of patch management that we would want to go through. So we're talking through this in regards to manual methods, and that begins with the first step of detection. We would use any detection tools at our disposal, such as those outlined previously in this course or other similar tools, and we would use those to scan against our web server. These can uncover missing security patches. It's also notable that if we are a customer of a particular hardware or software vendor, then we're likely to receive communication from that vendor, which contains updates about the latest hotfixes or patches for a particular product. Many vendors also make these available on their official website, or maybe through official news feeds, or even through their social media platforms. There are various places that we can find this information and even specifically subscribe to that depending on the vendors of the hardware or software that we have in our environment. So there are numerous ways that we can discover missing patches. The next step is assessment. In other words, you want to take a survey of the seriousness that the missing patch creates. In other words, does it fix a critical item, or is this simply an incremental update for a non-critical component? The way this assessment plays out could inform the timetable that you're going to use to install the patch. If this is critical, then you may want to install that as soon as possible, even before your normally scheduled patching window. If it's not critical, then you may choose to wait until a more convenient time. Next, you want to acquire the patch. Very simply, you download the latest update. You want to make sure that you're getting this from the official sources, that being the vendor's website, and also verify the integrity of the downloaded image through hashing. We've talked about that previously. Many vendors, when they offer software downloads or image downloads, they will provide things like MD5 hashes for the file. You could run the MD5 hash on the file itself after you download it just to verify the integrity of the image. After acquisition, it's a good idea to test the patch. More than once, I've seen patches absolutely wreck production machines when there was no testing taking place beforehand. So you want to designate either a single test machine that maybe isn't critical to the everyday function of the network, or ideally use a virtual lab device or a sandbox environment, and you would install and test the latest patch on that machine. You would want to observe for any adverse consequences and ensure that all operations function normally. If this is the case, then you can move to the next step, which is step 5, deployment. This is where we deploy the patch to every applicable device in the network. We've tested, we're not expecting any strange behaviors or adverse consequences from our production machines, but those are still possible in remote cases. So after wide-scale deployment, make sure you go back and check everything once again for any issues. It's also a good idea here to scan for those vulnerabilities once again and to confirm your patch status to ensure that the patching corrected any previously discovered issues. And of course, this is a cyclical process. Step 6 is maintenance. This is where you move into the phase where you're watching for any new notifications regarding vulnerabilities so that you can once again perform the necessary patching. This is a cycle you should continue, and this outlines manual patch deployment methods. Now, it's worth noting that there are many great automated patch tools out there as well. These automated patch management tools can scan the entire network to look for instances where patches are available. These can support multiple operating systems in many cases, like Windows, Mac OS, and Linux, and even specific third-party applications too. I'll point you to a few examples here just to close out this topic. First, you can see SolarWinds Patch Manager. SolarWinds is a highly respected name in the network solutions industry. We also have Patch Manager Plus from Manage Engine, another good solution. We have GFI LAN Guard, and one that I have used frequently is ConnectWise Automated Patch Management. So just a few tools I wanted to mention. Most of these are geared more specifically toward operating system patches and updates, but there are options built into some of these for automating the deployment of web server patches as well.